Hello guys. Okay. I said you in the earlier video that I will show you my code. Like this is my code in which I have linearized the system dynamics and I have discretized the system dynamics, and I'm using the time step. As you can see, the time horizon is like t equal to 300 and the time step or the time period is 0.01 second. And the dimension that I have used is 4 of them, which is the distance and the velocity, and the input I'm giving is two of them, which is acceleration in x direction and acceleration in y direction. As you can see, this one, right? So this one is acceleration, and I have a area of time, which is this one. I created using, this is a Python code, so I created using the linear space with the this time interval, and for this number of time for t equal to 300, okay, which is t plus 1 and t into t plus 1. And what I did for discretizing this one, what I did is I created a identity matrix, and I like it changes the like value at the position 0, 2 and 1, 3. Like I use sim as I have talked about that one. Let me show you my notes. As we talked about that one, like I simply had to do this one, like I plus AT, which means I already had system dynamics, and I added the identity matrix and I multiplied with whatever the time step I had. Like suppose I had the system dynamics, like from the research paper I got that system dynamics A from the research paper for the Quadrotor, like this one, and it was like 0 0 like 0 0 point, or it might be 0 and 1 0 and 0 0 0 0 0 0 1 0 0 0 0. Suppose like you have a system dynamics like this one, and like you, as you can see, this one like have two of the rows are 0 0. So like it will be very difficult to track. And so what you do is, like, this is not a discrete system dynamics, so you have to make a discrete system dynamics. In order to do that, you have to add a t, or t equal to 0.01 in my case, and which will be equal to I, which is identity matrix 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, like this one, plus 0 0 1 0 0 0 0 0 0 0 0 1 0 0 0 0, and multiply that one with this matrix with time step, that is 0.01, and eventually you'll get 1 0. This one will become 0.010 and 0 1 0 0 0 0. This one will become 1, okay, and 0.01 0 0 and 1. Okay, good. So I wrote this one in Python. Like first I assigned a equal to identity matrix, and then I simply change the position or the value at that position with my time step that I have. Okay, and in that way, like I got that value like at 0 1 2, so like 2. And what position is this one? Row is 0, so row 0 and 2, which is will be equal to 0. That's what like I did, and in that way I discretize the system dynamics. So this is how you discretize the system. But the thing is that this discretization that I have used is like stationary or constant for all the time period. But you can also discretize this one with at each and every time step, right? Using like difference method, like a finite difference method, or finite forward difference method, or finite backward difference method. Using that method, you can discretize that one at each and every time step. Okay, so after discretization, I simply put the A and B value. This one is the discretization of the B, and using this discretization, I have used that one into the system dynamics. I will let me show you. It is, I have used that one. Let me show you that one where I have used so that you can get an idea. Okay, here, like I'm using the iLQR method, so there is a forward pass and backward pass. So as I am using a trajectory flowing for the quadrotor, so for that one, okay, I'm sorry. So over here, as you can see, once I got the value of x and u, which is the optimal value of x and u, I then use that x and u value and put that value into my x, which is my system dynamics, which is a discrete system dynamics. So I'm using a, which is constant, but it is still discrete, which is dependent on time. So like, and I'm using xk and uk, which is given, which is like optimal value of the x and u at each time step that I found using the backward LQR method. Okay, so this is how you use discrete system dynamics and find or study the system behavior. So maybe you'll get more and more idea in the coming videos. Guys, please subscribe. Okay, please. Okay, uh, I will make more comprehensive videos. You'll get to know each and everything from here. And thank you. See you again. Please subscribe.